Hello, everyone. Welcome to the May 8th, 2024 Propeller Live Forum. Uh, we will have a short recording today. Just wanted to let you know a couple of messages that come from Ken. He couldn't be here today. One is that the Propeller Activity Board is still on sale. That's Ken's doing. If it was me, it would not be on sale anymore. So that sale's not going to last very long. So if you want to take advantage of that. And we were able to bring back the Flip Protoboard kit. We are making small batches at a time to bring it back into stock, and usually it goes out of stock and then we bring it back. So it's in stock right now. So today we will have an update from Jeff and then maybe something from Chip. So Jeff, do you want to get started on docs?
Yeah, I'm gonna share my screen.
And we have, if you are a Zoom user, we have had an update recently, so buttons may be somewhere else that it could be a little harder to find.
Yeah, it looks like
Something very funny just happened. I tried to rejoin the meeting and it kept asking me for passcode.
There's no
Now
passcode for this
That's
meeting, so yeah.
well, you do get a passcode in the email, and that one works inexplicably, but I don't know why it picks it up the first time, but then you have to put it back in from the email. I don't know. Very curious thing, and what I wanted to futz with didn't even work.
everybody see my screen?
Quality software engineering.
Looks good.
Okay, and do you see the other tabs at the top?
We do.
Yep. Okay, good. So I just wanted to point out that I'm working on documentation again. Mainly right now, the Propeller 2 spin manual that will eventually land, let's see, over here under Propeller 2 documentation, down in this area while it's being developed. And the point of this is to kind of expand upon the current Spin 2 language documentation that we have up there, and bring it to like the level that we had for the basic or for the Propeller 1 manual. So it's pretty rough right now. This is a little example I wanted to show you. Let's see here. So I'm going to be taking quite a bit of the material, mostly all of it, that's in that existing Spin 2 language documentation file and bringing it over, modifying some things a little bit, and then kind of mainly organizing it and adding some tutorials for various things. So one of the things I wanted to point out is right near the front is a category listing of the Spin language. I've always found that when I'm trying to learn a different programming language, I'd really love to have a upfront view of how things fit and where the boundaries are. So this I always find really helpful for myself. I come back and reference it quite often. So everything's organized here with a very short little description of what it does, what it's for, and the intent is for each of these things to be linked to the place in the manual where where it will describe it more fully. But if you want to come in, you're thinking about, oh, I got to configure something, you might find it in this section. That's something you would pretty much set for your application, for example. Here's some I/O control commands. Here's some things that's already linked. So here's an example of jumping to one of the flow control features with most of the same formatting as that we had in the Propeller 1 manual, with some differences because this is a Google Doc instead of a Word doc like we developed that first one, with various code examples showing a number of different ways to use the instruction and maybe some caveats or gotchas pointed out as well. Right up front, the intent is for there to be a pretty concise syntax listing with some bullet points of different parts of the syntax, and describes as concisely as I can what the point of that field is, and then more in-depth explanation down below. So I have, let's see, it's about 30 pages right now, with a lot more to expand upon, of course, in the coming days. And then at the end, I think there's about, I don't know, upwards of 200 symbols just for spin. So there's quite a lot to absorb. And in the back is a reserved word list that includes spin2 and pasm2 words. And I'll show you here. Here's the example that I'm actually working on, that you'll see a bunch of little highlights in different places that are notes to myself to come back to this, or this green means that I've cross-referenced that in a couple of different ways to make sure that it's proper. So this looks pretty hard to read right now. That's why I made a cleaner version to show you at first. But I also use this reserved word list at the end to verify various syntax items that were created in the Propeller tool a long time ago, which hasn't been updated in quite a while. I started working on it in January and then immediately got sidetracked. I need to get back to that. So anyway, this manual, or a cleaner looking version of it, will again appear on the documentation probably later this week. And again, it'll be a work in progress, so there'll be a lot of changes coming, and some formatting changes likely as well as it moves forward.
Looks good, Jeff. Hey, in the future, when I change that one Google Doc, will you get alerts?
Yeah, I do usually get alerts for that. And what I do when I'm developing this is I take a copy of where it sits at this moment, make that copy so that copy is static, and I mark it up with highlights for things that I have grabbed and moved over to whatever documentation I have, so that when you do updates, I go back and I can look at the history and see, okay, you changed this and that. I can see if it affects anything that I may have already grabbed, and then I update that stuff.
Good, okay. All righty, that sounds good.
I had a question, Jeff. What did you say you were using as your editor?
This is a Google Doc.
Okay, all right.
Yeah, so it's just web-based.
Yeah. Is anybody doing any QC work on this after you finish it or get certain sections completed?
So typically we've had somebody that goes through and edits things, handles looks for inconsistencies in formatting and stuff.
Right.
I'm not sure, we haven't had anybody assigned to that, but I've kept the same author list in the start of it until we decide on that. Occasionally I have Chip take a look at something, but I don't know if I would love to have, well, one of the points of having it as a Google Doc is so that anybody can come up there and make a comment on something, tell me, hey, this is wrong, or you forgot about this item, and then I'll go through and figure out what that stuff is and add that to the manual.
If somebody did
Actually,
that,
is
would
the
they actually affect the
patent doc
document
done
itself?
yet? No.
I'm sorry, there were two talking at once.
Go ahead, Ada.
Is the assembly doc actually finished?
No, it's not finished yet.
I just started the spin one. without having too much the other one.
Yeah,
Yeah,
just started the spin one to move it forward. At some point, I'll probably bounce back and forth between the two of them.
you've seen my thing, right? Because I've documented some of the weirder instructions in there.
Yes.
That's a bit non-obvious with some useful thing. Feel free to steal like the graph or whatever.
Well, yeah, Ada's done a lot of work on that stuff.
Yeah, thank you. Yeah, I intended to talk to you about that actually because it would be nice to borrow some of the learning that you've already done.
Yeah, just take it. It's what about it? It's just information.
I appreciate it.
Um,
And then somebody else had a question?
Yeah, I was just going to ask if somebody looks at this on Google Docs on the web and finds a mistake or something that needs to be changed, when they record that, I guess in that same document or whatever, then they're not able to change your text, are they? Directly.
No, they can suggest it by highlighting changes and putting comments in there. Actually, no, I take that back. We do usually have it set so that people can change it, but we get alerts to when those are changed and we can go review them right away. A lot of times, I'm sure Chips is very familiar with this. A lot of times people they go to type something thinking they're in a different window and start typing over the document and adding things to it.
Oh, yeah.
So we go through and we prune that stuff out.
Oh yeah, that's great. When someone just puts something irrelevant in there, like makes a minor formatting change, that shows up.
Yeah, you wanna have that all very well controlled, so not just anybody can make a change.
If you go into view mode, which inexplicably every time you reload the page, it drops you back into edit mode. But if you go into view mode and wait the like 10 seconds it needs to load, then you can't edit it accidentally. And also all the comments that other people have put in are removed. So that's best for reading these documents. But yeah, Google Docs is slow if you get past a few pages, or just in general. I have like a shitty laptop with like a first generation Intel Atom somewhere around here. I tried doing Google Docs on that thing, just like open it up in Firefox with nothing else running. You press a key and it takes like a second for the letter to appear.
Gosh, here it's pretty quick.
I mean, if you have a computer that's not really old, then it's kind of okay. But like LibreOffice on that same computer, perfectly fine. How odd. How could they have made it so slow? And of course, if you go back to like Word 95, that runs on like 4 megabytes of RAM and so yeah, don't even think about that. Remember GeoWrite for the Commodore 64?
I've used that.
So any more questions, documentation for Jeff, or we go to Chip and put him on the spot because he has nothing, I think, to present, but we can make him present something?
I mean, I can show some stuff that's not done.
Okay, we'll do that in a minute. What I've got to say, well, any questions for Jeff? Okay, I have been working with Stephen, and Stephen, actually, I forgot what we agreed on about what to talk about when, but
Stephen is trying to mute your microphone, so I think he,
no.
I think it's a shh.
That's where my time has been going, is to Stephen's stuff.
Yeah, I'm not.
Okay, you don't want to
That
talk about
face.
it yet.
Look at that face.
Yeah, where's Stephen's time's gone? I've made like 1 million bug reports for the VS Code extension because everything is broken.
Yeah, well, I'm sorry to hear that, and I am taking a look at them.
What?
We are at this point. We've made good progress with the compiler. we're working on USB interaction, and it's working on all three platforms. We are working on packaging now, and then we'll be ending with adding the debug statement support. And so we're getting ever closer. It's looking to be wonderfully stable. I don't know what else to say about it.
Yeah, so
I didn't want to
we-
go too far yet because we don't have a lot to show yet.
no, but we've got it running. I mean, it's doing the full compilation, telescopically with objects. It's doing the object distillation. The only thing it doesn't have is the debug stuff, but it's doing everything else the compiler, the Peanut does, which is what is in the Propeller tool.
Right. And so when we say everything it does, we're verifying binary file output, we're verifying object file output, and listing file output. And they are as close as we can get.
Yeah, so it's tacking on the flash loader, the clock setter, it's doing the interpreter too, right?
Yes, it is.
Did we verify OBJs on those?
Yes, we did.
I can't remember. Okay, so it's making data that's downloadable. So Stephen has been working on the USB side so that on all those platforms that stuff will work also.
Is there anything you found that you're not going to be able to do?
At this point, not. From the compile standpoint, we it's. I never like presenting things with having open technical questions, and so I'm studying packaging now for how to do it, and I'll be a lot more happy to talk about things when I have something that we can distribute and actually run on the different platforms.
Yeah, ideally it would just be like with all this JavaScript stuff, it might be a bit difficult to do it properly, but ideally you just want a single executable that does it. It just does whatever it does.
Yeah, we have a number of packages that are distributed in that way, and that's exactly what I'm studying to make sure we know how to do that.
Yeah, that's good. The other
Will
thing is the source code gonna be posted somewhere sensible?
Ultimately, yes.
Because there's a bunch of stuff that could be added that's somewhat easily if it's not like in a weird environment. Have you seen the compression stuff that I added to FlexSpin? So
No.
you know how when you download a file, it takes a long time into the P2 because it's only 2 megabit. And have you also thought about how a lot of that file is just empty because all the var space gets initialized to zeros and those zeros have to be uploaded? So
Dude, no,
eventually,
let's see. Well, in FlexSpin, those zeros get uploaded. In the Peanut compiler, which is in PropTool, which is what we translated into JavaScript or TypeScript, it actually initializes that space.
okay, I've never thought about that, but in the
I mean, it does it so the download's very compact.
on the P1, it did always clear the var space, and FlexSpin also does
always
that.
32K, yeah.
No, it doesn't. The stack gets cleared by the interpreter. It doesn't get cleared ever. But the var is included in the binary for the P1. So I just assumed it was the same. Anyways, if you have any sort of redundancy in your download, what I figured out is you can just put another thing in front of the code and then compress the code using like some sort of compression.
Awesome. What kind of compression does it use?
I've just used LZ4 because I understand how that works and can write like a decompression stub in like 5 minutes.
So Lempel-Ziv, which is kind of the best compression, right?
No, that's like the cheapest, basicest compression. It basically just, if there's a block of like 4 bytes that repeats, it can grab it.
Oh, so it's kind of like run length compression?
It can do run length compression by the sense that the block that it's sourcing from can overlap the block that it's going to write.
Okay.
So it can do run length compression sort of implicitly, but it can also do redundant compression. Now, this doesn't happen that often because you'd have to have text in your binary, like strings that contain the same words, or you'd have to have the same exact assembly instruction twice. So it isn't super effective, but you could use a more complex algorithm. I just didn't. And with bytecodes, it would having a sort of entropy coding would actually be like with Huffman trees would actually be very effective because the distribution of the different bytecodes is different, right? Some bytecodes happen all the time, some are really rare. So I'd have to figure out how to do that. It's really just changing out the code and of course the thing on the other side. And this makes the downloads quicker, primarily. But it also, if you want to store like binaries on the flash or something like that, it's also good. And that's a feature that I added in like 5 minutes on FlexSpin. No, not 5 minutes, it was like an hour or something. It was very quick to add. And then I had to fix all the bugs. And then Eric had to fix another bug.
And then you said there were a couple things we might attend to. What other things come to mind?
Well, you could add all sorts of useful things. Another thing that FlexSpin has that I find very useful is it can sort of basically move the origin of where the program actually starts. It's quite useful if you want something to be at a fixed address, or if you want to take advantage of the low address space to store some sort of aligned buffer. So instead of starting the program at 0, you may be starting it at 128K into the RAM. And you can either make it so that it assembles to just that address, so you can load it to there, or you can make it so that it just includes a bunch of zeros and the startup stuff at the beginning. I found that one useful. I use that all the time. You could add pre-processing probably quite easily. That's also all-time useful.
Yeah, Stevens has a preprocessor in it.
Oh, he's already added one. That's good.
Well, he had that working before we even started the compiler.
Oh.
Is that secret, Steven?
Not anymore. No worries.
So Steven had like a real long range like view of what he wanted to achieve. So the compiler is part of it, of course. And then there's other stuff.
Mysterious secret stuff. Ah, I see.
I just like to talk about it after we've gotten the technology proven.
I think Stephen had a lot of experience, and
yeah, he's like
some things you cannot implement, so or the project change as you work on it. So I think he's coming from that experience that he doesn't want to say because he may not be able to implement some things, some things will change.
He's like Elon Musk's mortal enemy. Like if they ever meet, they will probably have like a fight to the death. Because the ideologies are so opposed.
Well, Stephen likes Elon Musk a lot, so I don't think there'd be a conflict.
Well, that's in that case, certainly. Because that guy talks about things that don't even exist.
This is true. When we're in the idea realm, then it's okay. When I'm trying to produce something, I'm less happy about. But it's coming along wonderfully. I couldn't be happier in terms of progress we made and the outlook so far. I just want to make sure we can deliver it.
Well, is there anything else?
And
because I have my stupid thing and I need to go to bed soon.
Yeah, I do have to say publicly that I really appreciate Chip's help. It's been amazing. We've been finding, as we've been going through things, we've been studying, of course, very deeply how Peanut works. And we've been learning that. And as we find things, he's been correcting things in Peanut as well as we go. So it's been a good dual learning environment.
Oh yeah, Peanut with bug fixes, that's also good. Where do we have the... Because
I think my connection's kind of bad.
As it tends to be.
Yeah, you were pixelated right now.
Well, yeah, Steven's been the driver of this thing. I've been helping And I've had to like look at all this code because I don't remember how it works either. So oftentimes we get into a new section and it's like, all right, I got to figure out what it's doing because I can't recall myself. And then we figure it out and get it working and test it and move on to the next thing. Lots of that.
Anyways, want to see something really funny?
Sure.
Why not?
And by really funny, I mean not funny at all, actually. Because I found a silicon bug, a real one.
In
the P2, of course. Now check this amazing little piece of code out. See what happens here. We do an RD fast with bit 31. And then we do an RD byte. Now we see that we write the number 80 to sign base. Now you would expect that sin1 here gets the number 80 read into it, right? Regardless of what else is happening, unless it gets overwritten in memory.
You might.
Now watch this. No. Lexim -2 hardware bug.spin2 load P2 T 2 megabaud. Oops, I've got the other thing, the other terminal still running. Yeah, that doesn't work. I forgot to enable debugging. Amazing. It actually gets the value 15, but only if we're not waiting enough cycles in this wait X.
What?
Oh, well, yeah, when you do a read fast with a bit 31 set, then you have to wait enough cycles, right? And if you don't,
you have to wait for the RF byte. You have to wait for the RF byte, right? But this is not RF byte. This is the normal RD byte.
Oh, I see what you're saying. Oh, strange.
And even stranger is that it's reading a value 15. Now, earlier here, we're filling the memory, the entire memory, with dead beef. So where does 15 come from? I don't know.
Oh, it's that 512 if you juxtapose those first two digits.
Huh?
I'm joking. I don't know where it's coming from.
Maybe it's coming from the debugger. I don't know.
You had us both looking, though, Chip.
Because the debugger can't be overwritten, but nothing is reading from that address, so I don't know where it's getting anything from.
So this is an interesting. So this probably
The heck?
wouldn't. Yeah, you know, I don't think I ever anticipated anybody would do something like this. You know, but
I mean, it is kind of stupid because the RD byte, if it was working correctly, the RD byte would wait until this is finished anyways.
Right, but that hasn't maybe even engaged yet. That thing is in kind of a waiting state. It has to wait for the bus to come around, right? So get on the bus and then start streaming data in. So it might even be waiting for that event. And then the read byte, there's some kind of, I don't know what it's doing, but this seems like a place where there could be a bug. So I never thought anybody would do that. Once they do a read fast normally without bit 31, I don't, it would block until it was satisfied.
The normal RD fast works perfectly fine. And this is kind of something that you wouldn't maybe normally do. It just happened by accident, kind of, because I was trying to be clever in some code that really didn't need it.
What is the bit 31 telling us to do there?
So this bit 31 here is just a define to this. And basically, if you didn't know, if you do this, RD-fast is bit 31. RD-fast is a 2-cycle instruction in that case, instead of waiting for the actual
it
thing to
doesn't
be
block
ready.
until it's got the FIFO loaded. It just says, okay, we're going to start that process, then go off and continue executing code.
Yeah, what
then
you
it
normally
becomes
would
deterministic.
Yeah, exactly. What you normally want to do with this is very important if you want, because RD something something is always the worst kind of bottleneck in the P2. So what you can do is actually do something like RD fast bit that section bit 31 somewhere, and then you can go do 7 other instructions. It has to be at least 7, otherwise it will implode. And then you can go RF byte something.
Yeah, it's so rather than wait, because it's a variable amount of time, you don't know where the hub is.
So normally you would do like RD byte something somewhere. That's basically, so these are basically the same, this sequence and this sequence. However, this RD byte will take up to 16 cycles, between 9 and 16. And this will only take 4 cycles if you don't count those knobs, because they can be any instruction that you want.
You can be doing other work in between the two. So
yeah, basically this makes it. Basically, this makes your memory reads 2 to 4 times faster doing this crackhead method. And of course, if you want another byte that comes right afterwards, you can just do another RF byte.
Yeah, those are all 2-cycle instructions then.
And those are, and of course, it can also be an RF long. And then there's, of course, everyone's favorite RF var, which reads a variable length integer, which is, I think, actually used quite a lot in the spin interpreter.
That's the length encoded variable.
Yeah, exactly.
Right.
And this,
I'm with you.
And this, it reads in 2 cycles, which is why the bytecodes are small and fast.
Right.
4-bit one that would have been great for serving pixels.
What would be great for serving pixels?
If we had like an RF long, so like word long, so it'd go between a word and a long and get 24 bits. That would have been handy, because in the hardware, the streamer could have used that to get.
Yeah, that would be that's certainly something to add.
Yeah.
Yeah, that's a thing.
Yeah. So the idea of using read fast with bit 31 set in D is that you have to give it enough time, but you can put useful code in what would have been like a wait time that could have been variable, but now everything becomes deterministic in timing.
Mm-hmm.
Not just deterministic, but also just faster.
Yeah.
And that's actually, I've only really started using this recently, but now I've become mad with power and I use it for everything.
Good.
Because this is just how you bypass like the biggest bottleneck. So that's kind of, you got to do what you do.
Jeff, it's going to be fun seeing the explanations for these kind of things in the PASM docs.
I don't even think I have a particular explanation for this RD fast trick in my ones, even though I used it a lot now.
Yeah, this is an undocumented feature, right? Or actually, it's sort of, I mean, it's actually running the way it's intended to, I think, isn't it?
Yeah, I just never thought someone would do an RD fast with bit 31 set and then do an RD byte, because normally RD fast blocks until the FIFO is loaded. But so something's going to go wrong. If you don't let enough time go by, something's going to go wrong.
No, even it actually doesn't really go wrong. It actually just reads, if you do the RF byte here instead of the RD byte, you can actually see that it doesn't go horribly wrong. I have to load into Sin 1. You can actually see that it does not go horribly wrong. It just gives you a 0. which is probably not what you wanted, but it's not the weird corrupted value that you get here, that you get with the normal RD byte here.
Yeah.
Uh,
It's always 15, huh?
It's always 15. I've actually tried this on a different board as well. So but I think when I had the bug happen in the actual code, it was a different value. It was, I don't know what it was. I think it was 255 or something. I don't know. So it isn't always 15. It seems to read it from somewhere. Where was the actual code that had this issue? I think I've actually deleted it. I think I've restructured this since I found that. Now you might be asking, what is this nonsense? Where do I have the camera to show off what this nonsense is? Let's see. I have to disable screen share and enable the video. Because I still don't have my capture fixed. Say hi to Nitori. Oh, it's glitching the camera. Oh, great.
It looks stable here.
Okay, it's stable now. For me, it just glitched for a little bit. Anyways, check this nonsense out. Now loading. It sure is. Holy shit, it is Tempest 2000 for the Atari Jaguar, except it's no longer for the Atari Jaguar, it's for the Propeller now.
Nice. So is this
Mhm.
is this a whole nother platform?
No, this is not another emulator. This is just, I've taken the source code for the game, which has, through dubious means, made its way onto GitHub, and I just ported it.
Wow.
As you can see, it doesn't work quite right. This is really just because it's missing some screen effects. Because so the main source code is 68,000 assembly, so I just hooked up the 68,000 emulator that I already have. Great. However, all the drawing happens through these sort of microcodes for the sort of RISC processor that the Jaguar has. And that then in turn uses the blitter to draw things onto the screen. So what I have to do is actually port all that GPU code to run on the P2. Now, that's actually quite easy because it's just a RISC instruction set that's very similar, actually. But of course, I'm stupid and try to and make typos and try to make the code better while I translate it over. It's basically like line by line translation. And that's why it's been taking a while, because I have weird bugs happen to me. Yeah, this is, you can actually, there's controls. Look at the controller. And it then goes to this is one of, this is,
you know, this is you can't really implement any kind of anti-alias line drawing because the code is actually drawing the pixels, right?
I could implement anti-aliasing. I think the thing is, it's kind of tricky because, so you ever hear of the Atari Jaguar and how it works? It works in very strange ways. So the frame buffer is 16 bits, but they wanted it to be able to do smooth go-route shading. So they came up with this color space called CRY. Now the problem with CRY is that it's very difficult to figure out to sort of blend two colors together in CRY. And for compatibility, because I didn't want to change everything, I'm just doing CRY frame buffers and then converting them on the fly when they're sent to the monitor, using like a lookup table and all that. So it's actually kind of difficult to anti-alias the line of that. I could do it if it wasn't for that, and I could also just anti-alias them individually, but then they would have nasty seams between them. Or maybe I could do something silly like if I change the color of the pixel to the color of the line, but then I add the intensity maybe. Because CRY, the way it works is it has a byte that defines the color from like a set of 255. And then it has another byte that defines the brightness. And basically the one byte is used to look up a table in the ROM. So hard built into the video chip on the Jaguar, and the other ones are then sort of multiplied per component with that, and that builds a 24-bit color. And that's how that works. So it might be possible to add anti-aliasing to that. It might. And there's already an option to switch between thin lines and thick lines. So maybe I'll actually add anti-alias as an option. That's actually a really good idea.
So this was made in 1993, this Jaguar.
Yeah, it's like the cap. Wow.
Right.
And this is Tempest 2000, which was not made in the year 2000, believe it or not.
This is an AMD processor?
No, it's a 68000.
Oh, okay.
Again, it's made. If you look for Jaguar, it's the AMD did make something called the Jaguar, which is used in the PlayStation 4, oddly enough.
Right.
But this is the Atari Jaguar by Atari, and
Gotcha.
they made that in '93, and no one's ever heard of it because it's they sold like 100,000 units of it or something because it was a giant sucking machine.
Wow.
But it has this game on it, and many people say that's the best game on the system.
When did the Nintendo that took the CD-ROM, what was that called?
There is no Nintendo that takes CD-ROMs.
It was
outside of a
before. It was
prototype.
before the Commodore. It was before the Nintendo 64. Was it called PlayStation?
Yeah, but that's not by Nintendo. They did have something called the Nintendo PlayStation, of which like 3 prototypes exist. But then they pissed off Sony, and then they made their own PlayStation.
Oh, okay. Maybe it was a Sony product.
Yeah, this is before that even. This is like, but it's kind of the first thing that really uses like a frame buffer. Of course, you do get sometimes like a frame buffer on like other systems, on like the earlier systems, like on the SNES when you run Wolfenstein on that. That of course uses frame buffer, but this does have sprites. Well, not this. This is native Propeller 2. This is not a emulator, but the Jaguar does have sprites, and very good ones, in fact. But it also has enough RAM to do the frame buffer, and this is basically all frame buffer. What this game does. I can actually show you what some of that code looks like in comparison side by side. So this is. But I have to change this. Do I have the video disabled? Yes, good. So I don't have to hold the camera up anymore. Make it a bit smaller. You can see more. And so this on the right is my ported code. I'm going to open up on the left the original code. Let's pick something simple. Was this in Donkey or was it in Horse? The original source files have very interesting file names and very interesting things in them because Jeff Minter is like mildly insane in like a good way. So let's compare very simple microcode. So this draws the star background on the high score screen. And there's a bunch of macro definitions on this side. And this is pretty much the entirety of this microcode. That's why I chose this, because it's very short. And so on the P2 side, it has to load the overlay manually. On the Jaguar side, it loads the overlay. Loading happens in the 68000 code, so it's not visible here. So this is the RISC GPU microcode, and this is P2 equivalent. Now with this one, I actually kind of futzed a bit because I realized that so to use this ran macro here to generate a random, thanks for the scare quotes, Minter, position, which is interestingly basically the same as the CRC bit instruction on the P2. So So I put the CRC bit instruction in and it works. Very interesting. I also changed how the clipping works a little bit. Actually, this is a really bad example because I changed basically the entire thing. Oh no. Anyways, but you can see that the Jaguar GPU is basically just the same thing. It has an add instruction, it has a compare instruction, and has enough registers that you can rename them to what they are, right? And the bad thing is about this is that it has very interesting ways of branching. I don't know why this sometimes is, but sometimes it just has to do an indirect jump through a register, even if it's like goes all the way down here, like it has to load that pointer into this register and then it jumps through here. Why does it do that? I don't know. And also it doesn't have, it sometimes can't do what the P2 can do in one instruction because these are only 16-bit encoding. So here it can subtract 1 from n stars, but it couldn't subtract a bigger number. And for example, here it wants to add the number 511 into px, and it has to load it from a register. So when I find this, I can change it to be, well, this is this, here I scuffed it up using a stupid crackhead code. I need to find a different, overlay really quick. Maybe use the actual star field. That's from LlamaGas. There we go. That's a more interesting one. That might also have a good. And you see here, that's when I start these microcodes up, it always reads parameters from this inbuff location. And this is where I always use an RDFast to read them all in at once. And of course, I have to endian swap them here because big endian. And that's where I found the bug earlier, because I was having one with bit 31 set here, and then I was loading some sign values from a sign table. I could change it to use the Cordic, but I haven't. And then like all the rotations were wrong because it was loading the sign table from somewhere else. No, it wasn't loading it. It was loading garbage from the sign tables that way. And yeah, this is just what I've done a little bit for the last couple of days. This is just a silly little thing. The biggest issue actually with porting this over is that it twists your brain, because this uses like the Motorola style thing.
Big endian.
For one big endian when you're loading and saving into memory. But the other thing is that the destination operand is on the right.
Oh yeah.
So if I'm going, actually I've changed a bunch of things in this microcode as well. So if I have something like a SAR by 7, that's easy because the immediate is always on the same side, but yeah, if I have, I'm just rambling right now, sorry. If I have something where I subtract something, like a subtract where it's the same, I've changed the subtract here to sub reverse. I can't find a good example, I'm so sorry. There we go, display C, this line, which I've moved somewhere else, but it's still the same. So on the Jaguar side, it says add R1, R7. On the P2 side, it says add R7, R1. And if you forget to flip that, everything will implode and you will horrible. And of course, it's very easy to do when you're just porting many lines of code over. Many.
So is this the game that you're translating, or is like the microcode interpreter?
This is the graphics microcodes from the game. I call them microcodes. I don't think Atari calls them that, but they're very similar to.
Well, they're just 68,000 routines, right?
No, this is not 68,000. This is for the custom GPU.
Okay.
Right, these aren't 68,000, of course. 68,000 code looks like is in yak.s, very interesting file names. And it looks like this, which is like, 68,000 code looks like this. Jaguar GPU RISC code looks like this. And we call it a microcode because there's like a 4 kilobyte RAM that this all has to fit in.
So the GPU just executes the code that's in RAM.
Exactly. You put some code into its little 4K RAM, and then it just executes the code. And that's what makes the graphics happen. Either directly, like with the Starfield microcode, you can see it just has this store W, which stores a 16-bit value into RAM, and that makes individual little stars happen. But with something like the this was somewhere in this one as well. But with some other things, it might use the blitter. Now, the blitter on the Jaguar is an interesting thing. And one of the things that it can do directly is draw lines with shading. And that's what it, of course, uses to draw lines with shading.
Wow.
And there it just stores this into the blitter register. Of course, we don't have a blitter. So we do the only same thing then, which is rewrite it using crackhead code in a rep loop. So what this does back down here, we do the increase the shading value, which is because we're in CRY space, we only have to do one add, and then sort of like fudge it into the color word. Now, the weird thing is that we do a WR long because we're running in thick lines mode, and that really just means drawing two lines next to each other. Like in the original, you can see somewhere that it just moves the line one over and does it again. But we have the power of WR long, so we can do it in one pass. The other thing is this crazy thing to do the Bresenham line stepping. And then we just do WR long. Actually, I realized this is not using the thing. The FIFO. This should use a FIFO override. My life is a lie. Yeah, so that's that basically. I can't really say much more about this other than it's not done. And also there's going to be some pain with doing the audio because the audio, I don't think the source code to that is anywhere. It's just a binary file that's included into the Jaguar version.
Jeez.
You
mentioned overlays, Ada, and so what they're doing is they're reloading parts of that RAM.
Yeah, exactly. So for the for this Jaguar, this is this jack GPU file. Yak, not jack. This is. Do you know Jeff Minter likes animals? He actually like owns llamas in real life. Very interesting.
I believe that.
Anyways, so what this does is it uses the blitter, interestingly enough, to copy stuff into the GPU. Into GPU memory, and those are those GPU assembly files from down here. And those contain all the code and it has to load different ones because all the code for the game does not fit into 4K of RAM.
Yeah, that makes sense.
And these do basic things like drawing little polygon meshes or drawing line connected meshes, or drawing the star field, or drawing like a exploding text thing. Yeah, lots of exploding text things. So there's a lot of different ones. So over on the P2 side, so on the Jaguar, it actually has multiple different functions in one overlay. since we can load the overlays quicker and have sort of less space by comparison because we only have the 2K LUT. Well, I put it in a 2K LUT, and our instructions are twice as big. I have put every function into its own overlay, but they load faster, so it's fine.
So it doesn't switch overlays at runtime, right?
No, it switches them all the time, multiple times per frame.
Oh, okay.
So what I have this is some code that's stored in Cogram that's just common. So we have this cross-stacular thing here in my thing. So we check this GPU mailbox address. Is there something in there? Then if yes, first it checks where the screen is that it wants to draw to. If it's actually in hub RAM, the screen, because sometimes it ends up with a screen in PS RAM, and clear works, but everything else does not know about PS RAM and should not be. Just don't. And then it does this very inefficient thing where it checks, okay, is the command Miko GPU a single pix? Is the command Miko GPU texter? Is the command with this? All the different commands which you can find in this. Oh yeah, I made a bug report to Stephen about this. It does not like the VS Code extension does not like including files that aren't SPIN2 using the preprocessor. Because I've actually figured out that if you write a file that only contains symbol equals number, you can include this into the 68,000 assembly, but you can also include it into the SPIN2 const section. This is kind of very smart, I think. And the way that ends up being used is just go, I think Starfield is, so you can see it, I've just created this here. If defined Jaguar, it does the Jaguar sort of GPU call to the function we've seen earlier. And if Propeller, it just dumps the thing directly into the GPU mailbox and waits. I didn't bother making a subroutine. I just copy this everywhere.
Do you have suggestions for how I should know the file is SPIN2 code?
I mean, if I'm including it like this, then it's obviously SPIN2 code because I'm including it.
It doesn't have to be, but
I mean, if it's just a text include, right? So it must be SPIN2 code by that.
Okay, so you want me to assert that idea in the preprocessor?
Yeah, exactly. If it's pre-processing, it doesn't care about what the file is. It just includes it verbatim.
Okay, and you get what you get if you don't include SPIN2 syntax.
Exactly, and of course in this case we've got this very generic syntax that works for both the SPIN2 and the RMAC assembler. And yeah, the other thing is what you probably wanted to think about is where was that? That's in the top file. Is when this happens in FlexSpin specific code where you say libc up here.
Yes, exactly.
So this is actually nothing special. What this libc is actually just a libc.spin2 file that's included with the FlexSpin distribution in the default library folder.
Okay.
However, this file contains very interesting things. If I can find a copy of it.
So you're telling me the same thing. In object definition land, you want me to interpret them as SPIN2 as well? Well,
in this case, this is just a normal library. It is possible to include other languages, but in this case, you'd have to, like if I wanted to include a C library, I'd have to call it library.c. It will not automatically guess the extension. You have to specifically specify it.
So we'll only guess on SPIN2.
Exactly. If you do this, it will want to open a .spin2 file and parse it as SPIN2. But if you say .c, it will attempt to parse a C file. Of course, if you do just .spin, it will actually attempt to load a SPIN1 library, which it can do and is possible. And you can even load a basic library if you really want to.
Yeah, I have to walk the boundary very carefully between, as you know, I've elected to enable Flex support with its own switch so that we can do more advanced things that Peanut or Propeller tool can't do. When Flex is not turned on, I want it to be as close as possible to how Peanut sees the world and how Propeller tool sees the world. And so that's why a lot of these things are not working out of the box.
Oh yeah, this what's also a problem with this is that it can't find ones that are in a subdirectory.
Correct, because
Yeah, this is
not
kind
a
of a
feature.
bug with Propeller tool. I think it's not a problem to just ignore that because you will know that it's wrong as soon as you hit compile. And also that's arguably just a bug in the Propeller tool. I don't think Peanut actually ever had this because Peanut just, I think, just throws this directly at the wall if you whatever path you give it, right?
It won't process it if it has path name in it. It's illegal. And that's
That's
why
weird because I thought this was a Propeller tool specific issue because Propeller tool has this thing where it wants to be able to grab files that are open in a tab without going through the file system. And that's why I thought this was.
no, I
But
don't
normally in
think that both tools are limited to processing the current directory or the library directory.
that's very strange.
I understand correctly.
Because I thought that was very simplistic. Anyways, it should be able to do that if it I call that a bug anyways. So anyways, the libc.spin2. This is what FlexSpin has. So this is when I go see libc in a file, this is actually what it's including.
Nice.
As you can see, this is a very normal
Yeah, it's a
P2 spin
straightforward-
file.
it's a straightforward-
Except, oh no, obj anonymous libc.a.
Nothing I can do about that. Yeah.
Now, what libc.a does is actually very interesting. It pretends to be an R archive, but it really is not. This is just it's just a C file.
Sure.
I don't know why this is, but okay, just. And
is-
this then again defines all the files that are in libc using from file, which is
Right.
another interesting FlexSpin thing. But basically this makes it link in all the library functions. And by all of them, I mean some eclectic subset that I don't entirely know why some of them are missing. I've added some of them per pull request, but so basically this is how libc, and I use this because it's like the least bad way of loading a file from the SD card. Or in this case, I'm actually loading it using the 9p host file system, which is why it takes so long to load. But when I change the 68,000 code, it picks it up without having to pull the SD card out.
That's nice. Yep.
Genius. Anyways, this is not the only stupid project I have. I have an offer. You may notice that the screen appears to have crashed, but this is just because the game over thing is not implemented at all. If I press a button, it will start again. But it will soon stop because I have to close out of this terminal and go to the other terminal. What could it be? If you read the forum, you already know. Oh, it's another one of those emulators. And it has a silly name because I have to fit it into 8 characters somehow. It's a Super Nintendo emulator with an OU, right? Laugh. Anyways, it plays sometimes some games. That's kind of remarkable. Because the Super Nintendo is like the worst thing ever. It's so complicated. Okay. Your mother. Oh, look, it's like Zelda. And it actually works.
Fun.
Ada, have you done any more work on that, the 3D polygon drawing?
No, that's kind of fallen by the wayside. Start from Sanctuary. Because I've worked on this nonsense. And as you can see, this actually works for the most part. It would have sound if we had sound. But yeah, this game works anyways. I'll show you another one that works, which is cool. Keyboard is over there. Let's go for another one that's funny. F-Zero. I actually have a. Oh no. She almost fell over. But look, I actually have an actual F-Zero cartridge. Mental. It's almost bigger than the P2 board. Except it's not, because there's this giant RAM expander hanging off of it. Anyways, yeah, it's just F-Zero. I don't think I have to add anything to that other than that good game. And it works. You know what doesn't work? Actually, a lot of things don't work. But what's the most spectacularly failure? What's the most awful one? That I can demonstrate without having to click through it for like 5 minutes. Possibly Secret of Mana doesn't work. Yes. Yes. New game. Give it. No. A. This actually does work, but not for long. Yeah, that's actually a bad one. I'm not sure. Yeah, but this one almost works, but not quite. I'm not gonna go do that. I'm lazy. I made this entire thing from scratch, but then I was too lazy to go to show it off. No, wrong button. But it's a CPU test that it passes. Oh, guys, doesn't buy you anything. But it passes on the CPU test. I could do a whole nother like shitty PowerPoint on like the bizarre tricks that I had to pull to get it to this point. Because the actual graphic stuff, that one mostly works. And that's what I started with actually, because that one's like capital A awful. Because there's like up to 4 layers. And they have to be composite together, and then they have to be blended together. So there's like a transparency effect that's possible. Don't know anything where I can show off the stupid transparency effect. Yeah, I don't know. What has a transparency effect? I guess this has one, but it's like it's very basic and silly. Oh no, that's a much better idea. Jackie Crush. Yes. Give it to me. This game has a very interesting bug where it relies on the fact that when an interrupt is triggered, that the next instruction in the code gets to run before the CPU realizes that there's an interrupt. It's like it writes into the register to enable the interrupt, but then it has to run the instruction afterwards before going into the interrupt, otherwise death happens. Anyways, this has config. This has a real transparency effect. So anyways, this takes amazing amounts of CPU time to compute. Mostly because add pix is kind of slow. And also because it has to like mask it so it isn't like too many colors. Oh no, I am not skilled because I have to play with one hand. But yeah, this almost works. You can actually get the beta version of this in the forum. I'm not sure if I have any bug fixes that I haven't published there yet. But yeah, this is a silly little thing it can run. It's very boring because I've did it 2 times already, but this is, if you're technically interested in this sort of things, it's very interesting. I guess I should go to that part because that's more interesting. Than bad screen cap footage. It's like, oh man, it's like I'm watching a bootleg movie. Here we go. This is the horrible source code. All (8,875) lines of it. Oh, that someone asked for the thing in the chat. It's p2docs.github.io https : ::// there we go. That's the one you're looking for. Anyways, this is hell. This is all these 65.8.16 opcodes. Anyone remember the 65.8.16? That's like the greatest classics.
Oh, that's what the Apple IIgs had, right?
Yeah, exactly. Giant sucking machine. And this is all of its opcodes. Would you believe it? Also, there's this bug, Stephen. Why is this orange? Why is this orange? This isn't even disabled or anything. This is just bad and broken. Where is he? I have to see the look on his face. As he's muted, by the way.
Yeah, it makes it harder for you to hear me, doesn't it? Did you send me a link to that file so I can play?
This isn't specific to any file. It sort of happens when you add and remove things from a file. Well, I don't think I did that since I reloaded this window, so I don't know why it's happening now.
That would
Basically,
suggest I've got a reload problem in there.
Yeah, basically, one thing that's definitely an issue, any line that was at any point disabled stays disabled, even if it's no longer disabled.
Oh, that's not good.
Like it probably has like a list of line numbers that are disabled or something.
That's
and
correct.
It just never gets cleared.
It should be cleared every time we start. Okay, I'll double check that too.
No, it's correct when you start, but if you start editing the file, it sort of piles up with bad values.
Yeah, my sense of start is different. I'm sorry. The extension gets a whole bunch of notifications on changes that happen.
Oh yeah, and it repasses like the whole file.
Yes, every one of them.
So if you do this on these like 8,000 line files, it's very not good because sometimes it will get so slow. Sometimes reloading fixes it, sometimes not. I don't know what's happening. But it gets so slow that you type something and it takes like 5 seconds for it to notice that what I've just typed is not an error.
Yeah, I've got to look at that. I don't know that I have the option to change that, but I'll look into it and see if it's all about how the files get parsed and remembered. It's sometimes very difficult to go in the middle of something and understand where you are in the language.
Yeah, it's probably very difficult to pass the file incrementally.
Correct. And
well, you could do something. What you could do is, if you have a whole block, right, you could process the blocks individually.
Correct.
And then you can take like the CRC of the block, and if you see that exact same block again, you can just apply the same thing that you've cached.
Correct. There are techniques like that that we can use. Longer term, there's probably an even better technique. Right now, there are individual parsers for each block, and that's not as necessary as I thought it was. It turns out that I can use some of the compiler techniques that we've learned from porting Peanut to refine how I do parsing in the extension.
Yeah, that's most of the blocks are actually quite similar in terms of how the expressions are. Like the expressions that you can do in a dat block are actually the same as the expressions that you can do in a con block.
Yes.
Right?
Yep. And I hadn't known that efficiency when I first created it. And so there's going to be a lot of opportunity to make it better and faster over time.
Yeah, spin parsing is kind of interesting. I've messed with like FlexSpin's parser file. I've used like Bison parser, using Bison to generate a parser, and it needs a custom lexer to deal with like the indents and stuff.
Yeah, exactly.
And that file is hell because of that context sensitivity.
Yes, yes.
And
so yeah, we went a different route completely.
Why is arcade push?
Like that.
What's wrong with arcade push?
What has gone wrong with arcade push?
That's the wrong arcade push. Oh, it's orange for no appreciable reason.
Yep. It's decided it's bad and it doesn't like your code today. Sorry.
Yeah, it has gotten the SADs.
It's getting a little pissy, this thing.
Yeah, okay, it's the end of that. That should be just all of that.
That needs testing.
Anyways, the real star of this show is actually
lower, huh?
Some of the funny tricks that I found, some of which you may have indirectly heard about. So there's something special about the first 256 bytes of RAM, right? Because they're directly addressable. Now there's also something slightly less special about the next 64K of RAM, because you can fit the pointer into a word.
Oh, cute.
So if you're already putting all your code at the beginning of RAM, you can make your jump tables half as big, because it can just be words.
Interesting.
Great thing to do here. And this is just a jump table for all the crazy registers.
We had some people that had to leave. I've been monitoring the chat. I think it should be a good idea to stop the recording and open for discussion. And if we have something big, it will be better to talk about, present it on the next meeting.
Yeah.
Because now we have a handful of people left. The rest had to leave. So I can stop the recording and it's going to be posted in YouTube. And we are open for discussion.
Thank you, Ari.